Hello, today we are talking about tessellations. So this is the handout you should have. Up at the very top there is a website. I am going to be using this website to make some tessellations, so I suggest you write that down or pause your video now and key that into your browser so that you have this applet up so that you can manipulate some tessellations. So this first page is just basic information about a tessellation and examples of them. I'm going to scroll down. So these hexagons do tessellate. There's no gaps between them. If you look in your bathroom, you probably have tile in there. That's a tessellation. The floor in the school is a tessellation. The walls with cinder blocks are tessellations. Tessellations are everywhere. Sorry, scrolling down again. And they can be made with a single shape, tessellations, or they can be made with many shapes. So looking at this, we're going to move on to the next page now. Sorry, not the next page. We're going to look at this next page. Again, the site that I'm going to be accessing is up at the top. So if you did not put this into your web browser, please do so that you can access that. So what we're going to decide is, let's look at these figures and decide if they will tessellate the plane, which means I can connect them together with no holes or gaps. So I'm going to access the applet that I have above. Here it is. I'm going to start with the triangle. So I'm going to grab the triangle and I'm going to put a triangle into my picture. I need another triangle, and I need to put another one in. Not sure why I'm not putting it in. There we go. So I'm not dragging. You just drag them in. Now, right now, I can't really put them all together. This one doesn't quite fit. I need one in the middle. So if I add another triangle and I rotate it, so below the eraser tool is the rotate tool. I push on that once. Now I'm using the rotate tool. Now, whenever I click on my triangle, it's going to rotate a few degrees. So I'm going to rotate it until it looks like it's going to fit. Once I do, click in the white space, and then I'm no longer rotating. And I'm going to grab it and put it right in here. And again, could I continue with this pattern? And I could. I could keep adding and adding and adding triangles to this until I tessellate the plane and I have many of these put together. So I think that you can see at this point that triangle, a regular triangle, excuse me, will tessellate the plane. I could fill this space up with triangles. So that was the question for this, is will a triangle tessellate the plane? And this answer is yes. So that one will tessellate the plane. So the next one we're going to look at is the square. So if you've got the activity up, go ahead and pause the video here and pull that activity up on the website and do a square and see what you get. If you did not do that, I'm going to go ahead and go through and do it now. If you did that with your on your browser, go ahead and move on to the next shape. So right now, I need to clear this all off. Okay, so once I've done that, I'm going to use a square now. So let's see if a square will tessellate the plane. I hope this is making really funny noises for you too, because I'm hearing all kinds of interesting noises. And I think that we can tell by this that a square will definitively tessellate the plane. So coming back to this, yes, a square will tessellate the plane. So let's go on to the pentagon. So for the pentagon, Pentagon is a five-sided figure, so let's grab a couple of these and see if we can put them together. And we do have a regular one. You need some rotation, I believe. Okay. Okay, so right now I'm trying to put the pentagons together, and you can see I've got this white space right in here that I am not, that white triangle where I can't put anything in there when I have pentagons. I don't have a slice of a pentagon that I can put in there, which means this shape does not tessellate the plane. So going back to our handout, this does not tessellate the plane. So looking down for our next shape, Then we have a hexagon, a heptagon, and an octagon. So I would like for you right now to go through, practice with that applet, and see if these tessellate the plane. So pause your video here, go to the applet, do your hexagon, your heptagon, your octagon, and determine whether they tessellate the plane or not. Okay, like really, really do it. Like really key in that website. And if you didn't write it down, back up the video, write it down, go to that website, play with this, and see if you can get these to tessellate the plane. So please do that now. Okay, hope you did that. So we have that the hexagon did tessellate, the heptagon did not, and the octagon did not. Now, these shapes will not tessellate the plane by themselves. Together, some of them will with other shapes, but these by themselves will not. So next page of our handout is this one. So which of these shapes are going to tessellate? Now we cannot use the applet for this one. We just have to kind of think about it and figure it out. Now with a triangle, I could draw in another triangle right here, ultimately making a square when I have this right triangle. So yes, these are going to tessellate the plane. This trapezoid, I could draw another one up here, and then another one on its side over here. Where do I want this one? Upside down. Draw this upside down. Short guy, long guy, short guy. I think you can see that that will indeed tessellate the plane. I'm going to erase that one now. Actually, I'm not. Circle. I can't put circles next to circles and not create a gap. I'm going to have this gap right here. So a circle, anything curved will never tessellate the plane. So again, the next shape has this curvy part right here, so that's going to be a no. The next shape, could I repeat this pattern over and over and connect? So let's see, if I draw another one, and then I would draw one back here. Yes, so this shape is actually going to tessellate the plane. This one is a quadrilateral, and if I were to flip it upside down and rotate it, I would get this. So if I flipped the one with the star upside down and then flipped it over itself, I would match it up right here. And I could continue tessellating the plane with that one. So that one will tessellate the plane. So I would like you to try these last three. So pause the video now and determine whether the last three will tessellate the plane. So each of these is no. I need to be specific about this guy. Some arrows will tessellate the plane. It depends on how they're drawn. So that one, it's not that all arrows won't tessellate the plane. This particular arrow will not. The second one has curves in it, absolutely not. And the star, we just can't fit enough stuff in between to create a tessellation. So we are now moving on to the next page of your handout. So here we are. We're not going to be looking in our book. We are not going to be working as a group. Okay, so a pure tessellation is a tessellation that consists of congruent copies of one figure. For example, this isosceles trapezoid tessellates because none of the isosceles trapezoids overlap. So the shape that we were tessellating is actually just a single trapezoid flipped and slid over and over and over. Now, these are our rules. Tessellation must tile a floor that goes on forever, no overlaps. Tiles must be polygons, and each vertex must look the same. So a vertex is where all the corners meet. So let's talk about our triangle. The triangle, we've already decided, sorry, these are regular polygons, so all the angles are congruent, all the sides are congruent. We've already decided that triangle does tessellate the plane. We decided that by using our little applet. And what's the measure of one interior angle of a triangle? Okay, well, all the triangles add up to 180. Sorry, all the angles in a triangle add up to 180, and I have three angles, which means each angle is 60 degrees. And if the polygon tessellates, how many polygons meet at each vertex? I'm going to go back to my applet, and I'm going to get rid of what I have, maybe. Okay, so I'm going to pull my triangles in, And I'm going to go all the way around a single vertex. I have no idea how many I need. Okay, so let me rotate a couple of these. Okay, you can come down here. You can fit right there. You need to be rotated. And you, I got the right number. Let's see. You're going to fit right in here too. So now at one vertex, so here's one vertex. This red dot is a vertex of my tessellation. And the question is, how many triangles fit together here to form this vertex? So I've got 1, 2, 3, 4, 5, 6. So I have 6 total triangles that fit together around a single vertex. So if the polygon tessellates, how many polygons meet at each vertex? We had 6. And then multiply column 3 by column 4. Okay, so that's 6 times 60, and that is 360 degrees. So I got 360 degrees at any vertex. Let me go back to my applet and see if it makes sense. So the question is, all the way around that vertex should be 360 degrees. So that does make sense because around any vertex would be 360, halfway around would be 180. Back to our handout. So next thing is the quadrilateral. So the quadrilateral, how many sides? That had 4. Did that tessellate the plane? Yes. Now this is a regular quadrilateral, which actually means all sides are equal and all the angles are equal, which means it's a square. And the measure of one interior angle is 90 degrees. So I'm going back to my applet. And let's clean this up a little bit. And let's get some squares going now. Oh, okay, I've got enough. So how many squares do I have around a single vertex? And I have 1, 2, 3, 4 around a single vertex. Back to my handout. So I have 4. So now I need to multiply column 3 by column 4, and that's 90 times 4, and that is 360. So does that make sense? Going back to my applet. All the way around the point better be 360 degrees. And it is. So let's go back to my handout and see what shape I'm on now. Now I'm on a pentagon. So the pentagon had 5 sides. And did it tessellate the plane? And the answer is no. So let's find one interior angle. So to find the measure, one interior angle of a pentagon, I would do 5 minus 2 times 180. And I'm going to divide that by the number of sides, which is 5. And when I work that out, I get 3 times 180 divided by 5, and that is 108 degrees. Now this one does not tessellate the plane, so I actually want to look at this 360 thing. So I'm just writing in this space. This is not answering the question above. If I take 360 and divide by 108, that should tell me how many pentagons I need to make 360 degrees. And if you were to pick up your calculator and work that out, 360 divided by 108, you're going to get 3.3 repeating. So can I put 3 1/3 pentagons to create a tessellation? The answer is no. So if I divide and I get something with a decimal, that means it's not a tessellation. It cannot tessellate the plane. So hexagon. Hexagon has 6 sides. The hexagon did tessellate the plane. So let's try and do this without looking at the applet. Let's find one angle of a hexagon, one interior angle. So that's 6 minus 2 times 180, which is 4 times 180, and then I'm going to divide that by 6. So when I do 4 times 180 and divide by 6, I get 120. So let's do 360 and see if 120 goes into that. That should tell me how many hexagons I need at each vertex. 360 divided by 120 is 3. So I should need 3 hexagons to create a tessellation. And 3 times 120 is 360. Let's just double check that, make sure that this is actually correct. So I'm going back to the applet. And now I'm going to do hexagons, and I should need 3. Okay, so definitely need to do some rotating. So let's rotate this guy. That looks like about right. No, not, oh, it fixed it for me. Now I need to get this one to fit right here, and it does. So at this one point right here, all the way around is 360, and each angle was 120. And 120 times 3 is 360. So I've got a tessellation. Awesome. Back to my handout. Heptagon had 7 sides. It did not tessellate the plane. So let's figure out we have 7 minus 2 times 180 divided by 7. And I figure out that angle, and that is 128.571 maybe degrees. If I take that and divide 360 by that number, that's going to give me 2.8. Can I tessellate the plane with 2.8 heptagons? The answer is no. So that's why this is no. Octagon. Okay, so my octagon has 8 sides. So to find one interior angle is 8 minus 2 times 180 divided by 8. Work that out, and I get 135. So I would take 360 and divide by 135 to decide if an octagon will tessellate the plane. That gives me 2.66. I got a decimal value, which means the answer is no, an octagon will not tessellate the plane. So moving on to the last page of our handout. So what we need to know is what's the total degrees we have at this particular point. This is a tessellation with 2 different shapes. We need to figure out each of our shapes. So this first one, shape number 1 that we have here is octagon. Shape number 2 is an octagon. Oh, sorry, that's not the point that I want. This is the one I want, octagon. And then this shape right here is a square. So I need to know all my angles. Okay, so I should be able to find one interior angle of a regular octagon. In fact, I think I just found that on the page before, so I'm going to back up. And I did find that. Octagon, one angle is 135. So going back to where I was, I know that one angle in here is 135, which means the angle in the other octagon is 135. And I know in a square that each angle is going to be 90. So this is 90. So let's see, I should have 135 plus 135 plus 90, which is 270 plus 90, which is 360 degrees. All the way around the single point is 360. So every time you have a tessellation, when you find one vertex, everything around there should add to 360. So that should help us with these next 2. I apologize for the grouping of my figures. These should all tessellate and match up, and mine are kind of tilted. So for the first one, if I go all the way around this point, I should get 360 degrees. So I would take 115 plus x plus 42 plus 89, and that's equal to 360. Then I just need to work out my arithmetic. So this is x plus 246 is equal to 360, and then I subtract 246 from 360, and that gives me that x is equal to 114 degrees. And again, I just need to make sure that everything around adds to 360. So please pause the video here and complete the next one. Here's my solution. If you need to pause the video here to make any changes to your work, please do so. Okay, so we have 3 regular polygons that are always going to tessellate the plane every single time, and these are regular polygons. The first one we tried that worked is a triangle, and again, each angle, interior angle is 60 degrees, and that divides evenly into 360. The next one that we found was the quadrilateral, and again, when it's a regular quadrilateral that's really a square, and each angle is 90 degrees, and that divides evenly into 360. The last one is the hexagon, and that one, the interior angle is 120 degrees, and again, that divides evenly into 360. So those are the three regular polygons that will always tessellate the plane. So let's do these last couple questions. Do all triangles tessellate the plane? Now, we haven't actually talked about this, but yes, because all the angles in a triangle add to 180, and 180 will divide evenly into 360, then yes, all triangles will tessellate the plane. You can make any triangle you want, repeat that pattern over and over again, and it will tessellate the plane. Will all quadrilaterals tessellate the plane? Well, all the quadrilaterals add up to 360 degrees, which means as long as I can rotate the figure around to match up the angles so that I have one of each angle at a point, then yes, I will get 360 degrees at a vertex, which means any quadrilateral should tessellate the plane. Do all hexagons tessellate the plane? The answer to this is no. Only regular ones. Okay, any regular hexagon will, but non-regular hexagons do not. So non-regular would mean all of the angles are not congruent. So true or false? I would like for you to try the true or false questions. So please pause the video now and answer A through G. Here are my answers. So please check your work. If there are any questions that you have, please bring those to class with you, and I hope you have a wonderful evening.